We're going to review practice A for section 1.1. We've already done some of these problems using this diagram. We're going to do the rest in this section. So the first thing we'll do is just talk about the diagram. This flat surface is a plane. That's what it looks like when you draw it, or you see it on a worksheet. We're going to name this plane with a capitalized cursive letter. It's not a point that lives on the plane. It's the collection of all the points on the plane. There's other ways to name the plane also that we'll get to. But one note I like to make is maybe scratch out that F and make it a special looking F kind of off the plane so you don't think it's a point on the plane. On this plane, we have a line. There's also another named point on that plane. There's a line that goes through this plane at point B. This portion of the line goes above the plane, and this portion of the line goes below the plane. And notice how it's dashed here, because the plane is angled where we can't see this bottom portion of the line. But we do see it down here because, remember, this goes on forever. Okay, so hopefully visualizing that makes a decent difference for you. Okay, number 2 asks you to name 3 points that are collinear. Collinear means points on the same line. So if we look back at our diagram, here's a line. Here's 2 points on the line. And we know there's infinitely many points on a line. So there is a third one on here somewhere, but it doesn't have a name. So maybe that's not the line we're looking for. This line right here definitely has 3 points that are named. So they're connected with a line. That would be your answer. Point C, point B, and point D. Notice how I separate those with commas. You're naming a point with one capitalized letter. Okay, we'll go down to number 4. Name a point that is not coplanar with points A, B, and C. Coplanar means on the same plane. So if it's not coplanar, these would be things that are not on the same plane. So you want to find a point that is not on the same plane with points A, B, and C. It's helpful to think about that before you even look at the diagram. Okay, so are points A, B, and C on the same plane? In this diagram, you might say no, but the answer is yes. We have a postulate that we went over. Any 3 points make a plane. So even though you don't see it, that plane actually exists there. It's more of a vertical plane than this one being a horizontal one. Okay, a diagram that might help you, draw it like this. I'm just going to draw a box. Okay, so it's just like the room that you're in, it's a box. We'll put point A here. Now it's the same A from this diagram. We'll say that this is B. And notice how C is above B. We'll put C there. Isn't it a little bit easier to see that these 3 points are on a plane in this diagram? Okay, so we need a point that is not on this plane. Well, this plane is the front wall. Okay, so on our front wall, we have points C and B that are collinear with point D, like we just talked about. So point D lives somewhere down here. It's still on that front wall. What point is not on the front wall? Okay, well, point E, if you look at your original diagram, it's on the plane that you see. So that's like our floor in our room. Points A and B are on the floor. Point E is on the floor. But you see how point C is above? See how point D is below? Okay, so name a point that is not coplanar with points A, B, and C. A, B, and C are on the front wall. Point E is not on the front wall. Okay, some of you might have thought D is not on the front wall, but it is because it's in line with points C and B. So remember, planes go on forever, so D is going to live on that front wall. Number 5, give another name for segment CD. Okay, so start at C, end at D, all the points in between. Remember, naming segments is easy. You could just flip the letters. Number 6, name 3 rays with endpoint B. Here's B. We have a ray that goes up, we have a ray that goes to the left, we have a ray that goes down. Those are your 3 rays, but naming them sometimes is the challenge. If you have endpoint B, that means B is the first letter when you name your ray. So if I want to name this ray that goes up, I'm going to name it ray B, C, because we're going in the direction of C forever. And even though the ray goes up in our diagram, notice how in the shorthand notation, I'm pointing the arrowhead to the right. Our other rays would be ray BA. Again, you got to start at B. And the other one would be ray BD. These are the 3 answers. There's no wiggle room with these ones. You cannot reverse the letters. If you do, you're wrong. If you put the arrowhead in another spot, I don't know that I would consider it wrong, but we want it to point to the right so we're all on the same page. Number 7, name a pair of opposite rays. Simply put, remember, those are just rays that go in the opposite directions. Okay, so here's a good example. Ray BC goes directly up, ray BD goes directly down. B would be the endpoint for both rays. They make a line. Those are the 2 things you're looking for. So ray BC and ray BD. Anytime you name opposite rays, make sure B is the endpoint. B is the first letter. Okay? Number 8, give another name for ray CD. So we're starting at C, and going towards D forever. That's a ray. If you reverse the letters, that's not the same ray, because that ray would be now going upwards, not downwards. Can you think of another ray that goes downwards, or another way to name that same ray? Okay, so we have to have the same endpoint to be the same ray. We're going to go towards B forever. So ray CD and ray CB, different names for the same exact ray.